Welcome back to my new channel, Tech Tutor. I think it would be a good idea to slow things down a little bit and make sure that you're understanding all the basics. So today we will just discuss Java variables, and we'll also try to apply them to an end goal at the end of this Java series, such as building a very basic bank application. So there's many different types of Java variables, and if we're going to continue from our previous video, let's think about what a bank might want to do to store numbers. So if we're going to have this bank application to store numerical values, there's certain types of Java variables that you will use. So let's talk about them now. There are 6 basic types in Java to store numbers, and they are a byte, short, int, long, float, and double. If you want to store integers, the 4 types are byte, short, int, and long. And as you see in this diagram here, there's different ranges of values you can store in each of them. So a byte can only have values from -128 to 127. And a short can only store values from -32,768 to 32,767. And so on, as you see, integer value range and the long value range. You can still use a long to store numbers that would only fit inside a byte. It's just not as efficient if you know that the range of values you plan to store ahead of time is smaller than that. And as inverse, you cannot store a long value in a byte because the byte container is not large enough. In order to store decimal values, you will need to use the last 2 number types, which are a float or a double. And as you can see in this diagram here, a float can hold up to 7 decimal digits, and a double can hold up to 16 decimal digits. Again, you can store integer values in these variable types, but it would not be as efficient. However, you cannot use the integer types to store decimal values. After we have some variables to store numbers for our bank application, we will also need to store text. In order to store letters, there are 2 primary types in Java. The only primitive type that Java supports is a char, but Java also includes an implementation to help you store words called a string. A char stores a single Unicode character, which is most often letters and symbols, whereas a string is an array of chars, such as this array you see on the screen here, where it is storing the word words. And to simplify what an array is, just think of it as something in Java that helps you store a list of variables. So it is storing a list of chars, and each char is represented in this diagram. So W, O, R, D, and S. Or if you were just using the helper that Java has provided, you could say string word equals words and not have to store each individual letter inside of an array. The last data type we will talk about is used to store only 2 values, and it is called a Boolean. Something that we may want to store in a Boolean could be if a bank has an overdraft protection or not. And then the only values a Boolean can have is true or false. Let's jump back into our sample application now and make a few changes based on what we learned. In order to be able to store dollars and cents, let's change the balance variable from an int to a double and change the value from 0 to 0.00. So int to double and 0 to 0.00. And now we have some strings already in our code, so we'll go ahead and keep those. And as you can also see, we have a couple of lines to print the value of those strings as well. So we'll go ahead and leave those in there as well. And this scanner that we have will scan the input. But now let's change our deposit amount to a double. And it can still store the next int in a double because an int can be stored in a double, but then we would lose the decimals. So in order to store the decimals, we're going to need to change the value that the scanner is going to look for. So let's see what our options are. So if we go ahead and delete this and we hit dot, and now we see there's next int, next. And one thing I want to show you now is if you select something incorrect that cannot be stored in a double, such as you can see on the screen here that just next will return a string. and a semicolon on the end, it'll actually tell you this is invalid. It is incompatible types because you are wanting to store a double and it found a string, and it cannot store a string in a double. So let's go ahead again and look at our options. And so we'll go ahead to start narrowing things down. We'll just go ahead and start typing next. And as you start scrolling down here, you see your options, and all the way right here, as you can see, is next double, and it says it will return a double. So we'll go ahead and click enter and put a semicolon on the end. And now our scanner will read a double and store it into our new double deposit amount. And the last thing that we will want to do is add a Boolean to represent our example from earlier, which is overdraft protection. And we're going to end up setting it to true. So let's go ahead and add that line of code. So we'll say Boolean overdraft protection equals true. And the naming convention that we typically use for variables is what's called camel case. So that's why you're seeing the start with a lowercase o, and then the next word starts with a capital P. And if there was another word, it would also have a capital letter. So now we have a Boolean for overdraft protection. And then we're going to add one more line of code to print the value of our Boolean. And we'll say overdraft protection is, and then add it at the end here. And now it's going to tell you that it's always true, which is not our concern here, because for this particular case, we're not trying to use this Boolean to change it. This is just a simple example. So don't worry about this message, but we're going to go ahead and run it so you can see all of the values. So right click and click run. And now you'll see that it went ahead and it printed out my balance is 0.0. This is just because we didn't store any other values here. In fact, let's go ahead and stop it just for the example. We'll put a actual value here. We'll just say 15 cents, just so that way it's not rounding it down so you can see full example. Run it again. So now you see the balance is 15 cents. How much would you like to deposit? Let's go ahead and just say $1.99. We'll push enter. And now you can see that the deposit amount is $1.99. And you also see that it is pulling up your overdraft protection as true. So this is a simple example of the different variables that we'll use in order to build our bank application. And in our next video, we'll talk about the different logic of conditions that you can put in and how you would potentially use the Boolean values or check to see if your balance is greater than 0, if you're going to prevent something from overdrafting. So we'll continue on in the next video. And if you like this video, please like and subscribe. If you have any questions, please put them in the comments below and I'll be happy to answer them. And I'll see you in the next video.